William W. Hay Railroad Seminar Series is sponsored by the National University Rail Center here at the University of Illinois at Urbana-Champaign. And on behalf of all of us, we want to thank the US DOT as well as CN, BNSF, Anson Professional Services, and Union Pacific for their ongoing support of our program and the seminar series. It's greatly appreciated by everybody here on campus as well as those participating via the internet. I'd also like to extend a welcome to those of you joining us via the internet today, which includes the longest list I've ever seen. We have 125 people registered from dozens of organizations, so I'm not going to name them all, but we're certainly glad you could join us for this interesting seminar today. Yeah. Those of you who are dialing in or connecting via the internet and want to receive PDHs for your participation, please send LB Fry an email with your information as described in the email announcement for this seminar. So the implementation of positive train control in North America is driving various new innovations in rail technology. And these have the potential to fundamentally change rail economics, the way service is provided, how rail investments will be made, and substantially improve the competitiveness of the rail industry. Or they could be simply used to reduce operating costs. In this seminar, our speaker is going to explore one possible technology that could be used to leverage the PTC investment and its implications for the potential future of rail transport. Our speaker is Avery Grimes. He has over 40 years of experience in the rail transportation industry, including organizational restructuring, investment analysis, strategic planning, operations, engineering, economics, finance, and business development. He has held senior level positions at Class I freight railroads, including the Missouri Pacific, the Union Pacific, and the Kansas City Southern, regional and short-line railroads such as Omnitrax and Patriot Rail, and commuter railroads, Metrolink in LA and Metro here in Chicago. Avery completed his BS here at the University of Illinois in 1978, where he studied railroad engineering under Professor William Hay, the namesake for this seminar series. During that time, he also held his first transportation-related positions, working for CUNTD and in co-op positions with CTA in Chicago. After graduating, he worked for several decades in the rail sector, during which he completed an MS in civil engineering at the University of Nebraska, before returning to Illinois to complete his PhD in 2004. In his doctoral research, he developed new economic theories concerning freight rail investment and profit maximization, which he has put to use in his subsequent industry work since then. Dr. Grimes currently serves as Senior Advisor to the CEO at Patriot Rail Company. He has testified before the Surface Transportation Board on railroad economic theory and also serves as the Chairman of the Rail Group Executive Board at the Transportation Research Board. Please join me in welcoming Dr. Grimes, who's going to present remote control trains, moving block, and their effects on the future economics of railroading.
Thanks, Chris. It's great to be here. It really is a privilege to be here. The last time I spoke at a Hay seminar, is this too loud?
No.
Are the volume levels okay? Okay. Was in 2011. And we couldn't webcast it because I was getting ready to go to work for Metro as their deputy CEO. We were going through a management change there, we'll call it that. And I was talking about what we had done at Metrolink in terms of culture and changes there in safety culture, and that was after the Chatsworth incident. So it's really great to be back. This subject, which I think you all are all familiar with to some degree, I started thinking about this 2 years ago. And it was at our TRB conference, so I'm going to advertise for TRB here. I'm not speaking for TRB, but it was at a TRB conference and we started talking about the economics of automated trucks. Get rid of the cab, get rid of the driver, all of a sudden the costs become much more, the trucks start becoming much more efficient. And I could see then that this was, and a lot of people have been talking about this could be a real threat to the industry. But then we started really thinking about where are we, where could we go? And thinking about it in more detail. And I spent a year thinking about this, and then last fall, or last summer, I challenged, I have 8 committees that are under my purview. I started challenging my committees to start thinking about automated trains, automation. What does it really mean? And then they started a seminar, and then somehow or another I got asked to talk about the economics of it because that was an area that I found interesting. So Let me ask, how many people here have some economics background? You can raise your hands, okay? Anybody, you know what fixed costs are, variable costs? Okay, and sort of what those implications are. Do we have any, are you all with the, is there any faculty here from Illinois in the, okay, I was just curious on the, in the economics area. Okay, so we're going to talk a little bit about this. And a lot of this stuff stems from, a lot of these sort of concepts stem from my work with variable and fixed costs, doing my doctoral work. Anyway, so, you know, and as TRB chair, one of my jobs is to start, and Chris has challenged me, one of my jobs is to keep thinking about what do we need to know for 5, 10, 20 years, 30 years in advance. And that's one of the things that, that I started concentrating on, which I thought was a very key topic. So, again, I'm not representing railroads, I'm not representing TRB, I'm a lifelong railroader, and I want to make sure that that's pretty clear here. Now, I've given this talk twice before, sort of. It's based upon a presentation I made in January at the TRB Automated Trains seminar that we had, or session we had, and then more recently, and I effectively left the, sort of the title in here, actually had a long discussion with the SMART Union in August in Las Vegas at their convention. And I had 35 or so of the top people in the SMART Union, because labor is really an important part of this. And they're the ones that are could be most threatened by it if you take it the wrong way. But we're really, so that's why we've got some labor slides here later on in the presentation. Okay, objectives. Where's the current technology going to be in terms of long-haul train automation? I'm talking about long-haul trains here. Economic factors might influence this, and how technology is going to change those economic factors. Is it blue sky? A lot of people think this is blue sky. I'm going to tell you right now, a lot of people I've talked to, how can we be talking about this kind of thing? You know, this is way off. We don't know if this is going to happen. But I do think it's worthwhile thinking about the future. And I think the more, especially in the last few months, this is becoming more and more of a reality, especially since I found out about the French trials. And we'll talk a little bit about that for remote control train operation. So this is moving rapidly, and I think once the economics work out, it'll move rapidly, automation. And we'll talk about what that concept means, at least my view of it. And once it starts being useful, it will move very quickly. Blue sky, yeah. But there's a couple different outcomes for this. There's a few different outcomes, and that's what I want you to know. And then at the end of this, I want to talk about what are, I mean, there's a whole range of research needs that come out of this. A whole range of stuff, from economics to technical to safety to, I mean, so forth. So you as the leaders in terms of thought, or the future leaders of research, I'd like for you, if you're interested in rail, these are some of the key topics I think that we've got to start thinking about. Let's see. Chris read my abstract here. Let's see. Largely successful implementation of PTC is driving innovations in rail technology. It also changes the economics. It could change the economics, and then economics creates a whole different set of changes beyond that. All right? So think beyond what the next step is. Think about what's going to happen after that and what that next step is going to do to the next step. So, oh, I have it backwards. There we go. A little bit of the outline. We don't really need to go through this too much. So PTC will lead to new technologies. Any question on that? What is PTC doing? You all are all familiar with positive train control, right? Anybody?
You could talk about it a little bit.
All right. Positive train control. Foundation for the advanced starting point for moving block and remote control train technologies. Why? Advanced communication, location determination. We know where these trains virtually are, almost exactly where they are, I think, under positive train control. And correct me if I'm making two absolute statements. Computer-operated throttle and brake systems, relative location of other trains and track activities. These are some of the things that positive train control is doing. They're allowing the next layer of technology to be implemented in railroads, okay? Any questions on that? Integration with operating rules, so forth. It wasn't really meant to do this. I think there was some mind and some people who were advocating it years ago thinking, well, this could be the lead into the next layer of railroad automation. But really, in some ways, there was a little bit of kicking and screaming about, wow, the safety impacts the cost is far outweighed in terms of the safety impacts and the other better places. But really, this is setting the stage for future changes in rail automation. All right, the next slide. This is the research that's going on here. Right here, River City. I'm sorry, but right here, this is where some of the most advanced work is going on with moving block. And I'm going to bring up moving block because it's a fundamental change to some degree. And we're going to talk about fixed and variable costs. To some degree, moving block, well, first off, let's just talk about this. Wayside signals protect trains given the length of track which is protected by fixed signals. Anybody not familiar with that here? Okay, I think we do. They represent a fixed capacity cost. A train enters a block, the whole block becomes unavailable regardless of the train length. All right? One car, 150 cars, 200 cars. The whole block goes down, basically. And I'm overstating this because usually I'm talking to people who are not quite as informed as you all are. But moving block, because the only needed track is the length of the train plus its stopping distance. So it represents more of a variable cost than the fixed cost of fixed signals, all right? Not entirely. I mean, I've been pretty clear. I've been reading some of your papers and things like that. There's still a fixed cost component to stopping a train. But moving block represents a change to some degree from fixed capacity cost to a more variable capacity cost, because it's more based upon the length of the train. Not entirely, but to some degree it is. Studies in Europe have shown that moving block ETRMS increases capacity over fixed block by up to 25%. I think there's probably more recent studies. Virtual coupling, that's where you've got one train here, another train there, another train there, sort of following each other, and they're controlled as sort of a group. The studies I've seen in the passenger area show that virtual coupling can increase capacity up to 50%. But the studies at this point they're just studies, but I think they're very promising. And I stand to be updated by the people who are doing more work in this area. And then I've talked about, usually when I'm presenting this, I'm talking about the work that's being done here at the University of Illinois, led by Tyler Dick in this particular area. So Tyler, you're getting some advertising when I go out and talk a little bit. All right, remote control train operations. The kind of model I'm talking about is not the Australian model where they put out the track hundreds of miles in the desert and there really is not a person that is watching that train remotely. At least that's my understanding. They have a control center and basically it's sort of like I think they put it on automatic, although they're monitoring the whole system. What I'm talking about, and I think is much more achievable, and apparently I've just been informed of some trials that the French have done. The train operator is located in a stationary location. There's still a train operator. It's just not necessarily on that train. All right? It's like a drone pilot that's running planes out of Nevada in Afghanistan or wherever. That person sees what's going on, is controlling what is going on, but they're not in the compartment there. That person, he or she, is using computer-aided control over the train operation. And the operator may or may not, depending upon where the safety analysis goes, control 1, 2, 3, or 4 or more trains, depending upon the level of sophistication, the kind of the control systems, the kind of difficulties they're running into in the territory, and the kind of decisions that a human has to make in this kind of operation. And for now, we're really talking about the long-haul train operational concept, where there's very minimal, if any, switching of cars that goes on. I don't think we're there yet in terms of automatic couplers and things like that to be able to automate the actual work that has to happen in industry. In some cases, this is a lot like trucks. I think we're a long way from having automated trucks in urban areas. But over the long haul, it's happening. It's going to happen soon. Now, what does this do to the costs of operating a train? And I'm going to go back to that first question I had on the first slide is, why are long trains long? All right. Fixed costs of running that train?
408 students know the answer.
Okay. You got a crew. You can, with that crew, now with distributed power and things like that, and we didn't have this back when I first started. You have distributed power. You can run a 200 car. You could theoretically run almost an infinitely long train, I would suppose, under that scenario. But you've got one cost. When you start a crew, when you do a train start, you've got a cost associated with that. You've got to have the crew. Again, regardless, 1 car, 100 cars. That's a fixed cost on a per train basis, right? So what happens if you don't need a crew? Your fixed cost goes away. So what's the incentive to run a long train? All right? I'm not saying the crew cost is going to go away. It's going to be diminished. We're not going to do away with crews, I don't think. But what happens if the crew cost is significantly diminished? Well, the need to run the efficiencies, to get the efficiencies, you don't really need to run long trains. You can run shorter trains, right? Because now your fixed costs are going down and your variable costs are more of an important situation, part to the equation. If you had, let's say right now we are running 2-man crews virtually on all of our long-haul trains, and if you were able to run 1 person with 2 trains, well, you would reduce your crew costs by 75%, right? So it significantly reduces the fixed costs. So what are the variable costs with running a train? Well, locomotives are kind of a lumpy variable cost. What we call lumpy variable cost. You put a locomotive on there, you're going to want to maximize the value of that asset. I don't know, 25 cars, 30 cars, wherever we're at nowadays, we're running very high power 6-axle locomotives. So one of the questions is, in a way, do we really need to run big locomotives in the future? I know that there's efficiency associated with that. Infrastructure maintenance is considered a variable cost, wear and tear, although not entirely. I think there are some fixed costs to running infrastructure maintenance for those components which are, what do we call it, like such the accidents, a grade crossing hits where just hitting it for the first time is part of the wear. But I think largely infrastructure maintenance is considered a variable cost with gross tonnage. Fuel is clearly a variable cost. Let's see. So, again, what happens here? Why, if we can take the person out of the cab and have that person run 1, 2, 3, or 4 or more trains, so we're vastly reducing the fixed costs. So the potential directions, I think actually I may skip this one. One potential outcome of this is to simply cut jobs and labor costs. We're going to keep running big trains, but we're going to have fewer crews. No change in overall operations or service design. Use roving conductors, more technical oriented engineers. But is this the most likely outcome? In other words, we don't change anything about the way we run trains. We just take the crews off of them, right? That's one potential direction. Another direction, a potential outcome, is to entirely change the way the service design is done, the model, given the new economics of railroading that could be possible with these technologies. It's a different perspective. Low fixed cost per train cost structure. I'm sure there's more than two outcomes, but these are the two that I'm concerned with. So, what happens if fixed per train operating costs are reduced by up to 75% and fixed per train capacity costs, that's why we're talking about moving block, are reduced by 25% or more? Well, obviously, less train size becomes less of an important factor in operating efficiency. And then we start looking at, well, what are the efficiencies of short trains? They begin, as this equation changes, the efficiencies of a big train or a long train start to go down, and the efficiencies for short trains start to come up. And what are those? What are those potential efficiencies? Well, little or no intermediate switching. If you can get your short trains to run from near origin to near destination, skip those intermediate terminals. Well, there's a lot of time spent in those intermediate terminals for most cars. And this is one of the areas that I think some research, again, there's research in a lot of these areas, but this is one. Faster train assembly. Instead of putting together a 200-car train or 150-car train, you can pump out those 30, 35-car trains probably faster. And I think there are some efficiencies more than just the per-car efficiency, because a big thing is hard to put together sometimes in some of these smaller yards, right? We don't know what that is. Car velocity improvements. I'm using this 40%. Okay, well, I see. Yeah, okay. I don't have it on here. Car velocity improvements. I've seen studies that are old that say that cars spend about 40% of their time in intermediate terminals. It's being switched, but that's forced because it's going from one train to the next train, changing destinations. But if you have trains that are small enough that they can go from near origin to near destination, think how much more efficient that is. We don't have to go to North Platte, to Salt Lake, to, Las Vegas, and then finally get into the final train to get to the destination, Commerce City. That's something that we don't really know. I did a back of the envelope with a BNSF person the other day when I was in Fort Worth, and they said their back of the envelope says cars spend an average of 30% of their time, and BN's a more unit train type of a railroad than, say, Union Pacific. So they think it's around 30%, just back of the envelope. I've heard, in fact, I thought I saw some research here. Yeah, that was up to 50% or something like that. Okay. So also, locomotive utilization improvements. If you can turn these things faster and avoid the intermediate stations, think about how much time that saves on locomotives at each of the intermediate terminals where they come off the train and then are replaced on another train. Freight inventory and transit. If you can move your shipments, in this case the train size shipments, faster from origin to destination, skip that 40% of the time in those intermediate terminals. Think about what that does to the most expensive component on a railroad today, and that's actually the inventory that's in the trains. So that's an important thing. The railroads don't necessarily benefit directly from it, the customers do. So a big part of this is what this does for customers. Less congestion in complex terminals like Chicago and Houston. I've heard over and over again that, for example, in Chicago, when I was up there, how when one of these railroads, CP, CN, or others, bring in a huge train into the middle of Chicago, it ties up everything, right? So smaller trains can move more quickly in complex terminals. Improve service reliability. And this is a big one too. One of the biggest issues that railroads have is being able to say, we know if it leaves this day, it's going to arrive on this day, right? But there's all these events that take place in between. You reduce the number of events in between origin and destination, you do get better service reliability. Okay. So what happens, and I've said this, the economic scale starts shifting. And that's what you've got to think about. This is not a switch from 1 to 2. These are scales that tend to shift. The economic decisions start being made that support this kind of operation over that kind of operation. All right, service design, investment, and customers. So, if you take this concept forward, what does this mean? Service design, long haul, more frequent service with OD, more OD pairing. And I'm saying operating from origin to destination. I'm talking about really from near origin to near destination. Your yards, instead of being in the middle of the country, they will be closer to the major areas where production and consumption are taking place. There is some tendency to operate train length around locomotive capability, and there'll be less congestion in major terminals like Chicago, Houston, and LA. Rail investment. Where does rail investment go? The last 2 or 3 years, UP's been, I don't know if it's still going on or not, but they've been talking about spending something like $1 billion, $1.5 billion for a major switching yard in the middle of Texas, Brazos Yard. That's a really expensive proposition. They really need it to sort stuff, and there may be reasons they would still go along with it. But your investment is going to tend to go from necessarily switching terminals to focusing on intermediate line capacity, where with more capacity, more structured around the kind of things that will benefit from moving block when that comes, that's where our focus of investment is going to take place. If we improve car utilization, if we reduce the time fundamentally from origin to destination, think about the reduction in car investment that takes place, better utilization. Greater focus on locomotive reliability. We're going to have less of this second and third redundant power. We're going to have to make sure locomotives operate without failure. A lot of that has taken place over the last 10, 20, 30 years. And we talked about more investment in near origin and destination switching facilities. From the customer viewpoint, this is really where it's exciting to me. Faster service and inventory and transit savings. More reliable service, fewer events to get from origin to destination, and lower equipment costs, which are generally paid by the shipper, but that has a lot to do with whether the shipper is attracted to highway or to rail, and those very marginal economics that lead one to make a decision for one versus the other. Right? Okay, so this is the aha kind of thing. Lower costs, better service, what happens? Could operating ratios drop below 50? Lower costs, increased revenue. Or I should say lower costs, increased margin, and probably I should put that there. Lower rates, I think to some degree, because the general agreement is as costs go down for railroads, costs go down for everybody to some degree. They're shared. It hasn't been all that true here more recently because we haven't had the productivity gains to share with customers in the rail business. But if you get productivity gains, generally speaking, the railroads have shared that with customers. I mean, it's not a line item on the tariff, but there's less of a tendency to keep raising rates just because your costs are going up. Service reliability improves. The secondary economics effects start to take place. Rail becomes more attractive. It's more reliable. There's less cost in terms of equipment to move it. It becomes much more truck competitive. What happens? Growth. Obviously. And this is where I don't think a lot of people are realizing once you start making this industry that much more reliable and efficient, then we really can start to do a better job of pulling what I feel is necessary. The reason I went into this business is to move more and more traffic off the highway and onto rail where it's more efficient, better environmental effects, so forth. So, okay, good, all right. So growth in the number of trains, a shorter train effect, combined with business growth, will tend to offset train and engine job losses from automation. Just cutting positions loses the long-term benefits and really creates a war with rail labor, and that doesn't help anybody. Railroads will save money and move faster with labor if they look at preserving these jobs. And you're going to say, well, why should we preserve the jobs? Well, if we start running shorter trains, even if we have one person overseeing 1, 2, or 3 trains, there's an effect there. We're going to have jobs in headquarters. There's still going to be cost savings. You don't have deadheading. You don't have necessarily overtime. You don't have a lot of the costs that you incur because the crews are in the field, moving them to the field, and then getting them back home. It becomes a regular job for an engineer. He goes to the office. It's right next to the dispatch center. He gets his orders. He goes to a module. In this module, he can see, he's got cameras. He can see above, down below. Where have I talked about that? I think I skipped that. So imagine you're sitting there. Let me just make sure I'm not covering this concept. And I did skip over it. Okay, excuse me. So imagine the operator, the engineer, goes to work. He can see what's going on, not only ahead of him, but he can see on the ground. He can see to the sides. There's cameras all over this thing. Imagine when you step into your car these days. How many people have been in a car where you step in the car and you look at the screen and it's got a 360 picture around you based upon connecting links? Anybody seen that? It's amazing. It's amazing technology, and it's there today. You can do the same thing with a train. You got to have higher bandwidth. You got to have higher communications with those kind of restrictions on the technology side, but that's coming, I believe. Furthermore, this train can talk. All right? Officer comes up, says, "What are you doing here? You're blocking my crossing." He doesn't see anybody, but there's cameras, and there's a microphone. And all of a sudden, the locomotive response said, "Yes, sir, we're talking to the dispatcher now. We've got an accident up here. We're getting ready to make a reverse move to open up this crossing." So the train actually can talk. Probably easier than a real engineer could up there, because he's shouting down over the sound of this locomotive, all right? The locomotive can hear. There are a lot of things that we can make a locomotive do that can talk to a person remotely that really do make that locomotive able to respond to the people on the ground in a way somewhat better than what they can today. How many people have been on a locomotive? Anybody? All right. I used to be a licensed locomotive engineer. I was appalled by what I couldn't see. I couldn't see my men on the ground. I couldn't see around, really. I'm on this giant piece of equipment. It's making a ton of noise behind me, and I'm a little disoriented. But what I could do, from a remote spot, the cameras all over this thing, I could see better. I could talk to the people on the ground. I could respond better to these people who are trying to communicate with the railroad. Okay, I sort of am jumping over this. So, benefits. Road T&E, or labor, stabilizes more trains and more freight. Job guarantees. One of the things I believe, again, this is my opinion, that the railroads have got to start thinking about, and labor, is negotiating a job guarantee. All right? Otherwise, labor's going to fight, it's going to be delayed, and in fact, some of the benefits of technology need to be shared with labor. It's my personal thought. We've always had a partnership there. Job guarantees, job level guarantees, and productivity pay. Because even if we're running more trains, we may not have a position for all those engineers that we're taking off, but when growth occurs, there'll be more and more of those trains. And I do think that we can preserve these jobs, even these job levels for the railroads. And that is something that a lot of people, that labor can't get there. I don't think labor really appreciates unless they start thinking about what this does for the long run, for their profession. The jobs will change. They've got to be higher tech. They're going to have more responsibilities. We're going to preserve the jobs, but the jobs have to change, right? This has happened time and time again in the rail industry. A better, safer work environment. Non-T&E labor force growth. If we get growth, because we've got lower costs, better service, then all the other jobs on the railroad start. There's more work there as well, maintaining the track, constructing track, all those kinds of other occupations. National transportation policy. Well, I think you all know we have, for a long time, recognized that we need to bring more and more traffic off of highways onto rail. If we're going to preserve highway capacity, preserve highways damage, reduce highway damage, and so forth. It's a national policy we'd like to do, but so far most of the things I've seen have been sort of regulatory in nature. This is economic in nature. AASHTO Freight Rail Bottom Line Report talks about the need for this, and that's, what, 2008, I think that was issued. STB economic regulatory changes are going to be needed. The way we generally regulate prices today is on this ratio of revenue to variable cost. That's the R over VC ratio, and its relationship to a 180 ratio, and if it's over that, then there's a potential for monopoly power, I should say, abusive monopoly power, and there's a lot of issues that go into when they take oversight, but that's one of them. So what happens when your variable costs start halving? I mean, if they're reduced by half, well, then we've got to start thinking about changes in our economic regulatory scheme. Rail investors, well, rail value improves. Not because it's just cheaper, because it's growing. And growth is the real aim here. So, I've actually got, this is summary and concluding thoughts, but I've actually got a couple more slides after this. The benefits are significant and have to be shared. And I'm talking about not just among investors, but also customers, if we're going to have growth, as well as rail labor, because they're partners in this. Labor and management have to work together. Who's going to lead? Right? That's a big issue here, because labor can stop stuff for a while. When we got rid of, when we went from steam to diesel, it took about 25 years eventually for us to get rid of firemen. That was a pretty successful part on the union. They kept those jobs even though there was no firebox, right, to feed. The clerks, when computer automation came along, that went really quick, and the clerks union went away fairly quickly, as I recall. So, you can fight some of this stuff, but eventually technology is going to win because it's more efficient, it's better for the nation. Management has to focus on these new technologies. And right now I only know of one, of course they're kind of closed-mouthed, but I only know of one Class 1 rail system right now is looking at new technologies. I know that they're focusing on moving block, and I know this personally from them, so I'm not exposing any private information here. It's Burlington Northern. They're working on moving block, and Siemens is working on it for them. This change will involve incremental yet steady adaptation. This is not an overnight kind of thing, clearly. Important lessons will be learned along the way. A lot of research has to be done. Public acceptance, I think, will come with shorter, smarter trains. And I've talked to a number of people, I've not done a survey or anything like that, but I've talked to a number of people in the public arena who say, if we had a choice for grade crossing issues, we'd rather have shorter, frequent trains that will clear up, and we know we're going to clear up, than these longer trains, and we don't know how long they are, and we're going to have to sit there at the crossing. So I think public acceptance would be, even though there's more trains, shorter trains that clear up quickly, I think the public can accept that more. But that's a key issue, is the public acceptance. Technology is changing competition, and railroads must meet that challenge. Otherwise, the trucks will get there on the long haul stuff. If that happens, we have a problem, because distribution networks will be set up around efficiencies, high truck efficiencies, if railroads don't get there first, or at least at the same time. Once you start having a distribution network, DC, set up around a particular efficient mode of transportation, they're really hard to change, because money is in the ground. But the rail industry, at least at this point, has the advantage, because you've got a separated highway, you've got a separate right-of-way from the public. These last two slides, this is one that I presented to labor unions in August. You got to look at it from a couple of viewpoints. I wanted them to think about, what are management considerations here? Well, first off, are short trains, or the advantages of short trains, real and significant? I think they are, but I'm not doing any calculations at this point. I have no quantitative data to back it up. Investors. Are investors here for the short run and the long run? If you're a short run investor, give me the cost savings now, let the stock go up, and then I'll get out. Right? If you're a long haul investor, you have a different consideration. I want to know where the long haul growth is going to come. How much is labor cooperation worth? If I'm management, do I really need labor to work with me? Or maybe I can fight them, right? I think they're better off working with them. Will long-term growth come, and if so, how soon? It really depends on the incremental nature of this implementation. Labor considerations, do we fight or do we engage? Personally, I think it's better when you engage and you're upfront about what is coming and how do we share the benefits of this. How long can labor hold off changes in the technology? Again, we go to the firemen's union versus the clerks' union example. What does history suggest? How will rail jobs change? Technology, types, locations. Instead of being out in Gibson, Nebraska, you're going to be in Omaha. Those kinds of things. That's a big deal and part of the issues for labor unions. And what is the best negotiating strategy for unions? So some of the discussions that I had with them recently. Now, one more page. How are we doing on time? Oh gosh. I know, but a little bit of. So, I just put these down, and I'm sure it doesn't cover the full spectrum. Thoughts on rail research. How would these onboard trains actually work? Systems work. Cameras, data flow. How much can computers actually manage? How much can the communication systems actually handle reliably? So there's a lot of technical issues here. And safety risk management. How many trains can one engineer monitor, and under what conditions? Are you in Chicago or are you in rural Wyoming? That's a safety risk research issue I have. What level of distraction is required to run a train? Of course, it depends on how well the computers are taking over, right? Can he manage 2, 3, 4, 5? And under what conditions? He or she, I should say. What is the public perception under the safety and risk management? Are these drone trains running through the night and they're going to carry a nuclear bomb and blow up our town? I mean, you've seen those stories. This is on webcast, so I have to be careful here. Markets, logistics and aggregation markets. What is near origin? What is near destination? There have been some studies I've heard of that show that actually there are fewer origins and destinations than you might think for rail traffic in this country. It's still in the thousands, but is it 20,000 or is it 3,000? How close can we get to the customer? In some cases, the customer gets enough, we can run trains just for that customer. In some cases, we can get pretty close. What does that mean? We don't know what that means. That's a whole area of research in itself, the logistics aspects. Engineering, industrial engineering, customer aspects. How would this kind of regular service improve customer operations and customer efficiencies? What is true value to the customer? We need to understand what the value is that we're creating here for customers by speeding this up. Because that has a lot to do with how much we're going to attract. Service design, how much actual time savings with remote operations and reduced intermediate switching. What are we really going to save? How attractive is that avoidance of those intermediate terminals? Do we really save 40%? Do we really save 30%? I don't know, but it's stuff that we need to figure out. Service design, okay. How much actual time savings with remote operations and reduced intermediate switching? How much field work is actually needed for these long haul trains? We've talked about, you've heard the concept of roving conductors. What do we really need in the field for these kind of operations? All right? What do we do in case of a derailment? I'm going to tell you right now, the crew does some things in terms of a derailment, but not a lot. You really got to send people in that can actually deal with that, with the equipment and the training. Economic. What are the true costs and realistic savings from these changes? How much inventory is really needed? What if we reduced rail inventory on rail by half in this country? What would that do for our national productivity of our plants, our facilities, our supply chains? What are the value shifts of the broader economy and national competitive effects on overall manufacturing? If we really go as a nation to the next level in technology and have the most efficient and most service responsive rail network probably in the world, what does that do for us, for our country? And I don't need to actually turn it into a patriotic kind of thing, but those are all things, and I think these are the things that I think you all ought to be thinking about. This stuff is on the horizon, and it's amazing stuff. And you as researchers, as potential researchers, people who are learning about these things, you've got a great future in this business because there's so much more to go than where we are today. With that, I think we've got about 12 minutes for Q&A. Okay. So I'm trying to think of a major concluding statement. I think I just did it. You're in a great place to be. And some of the best work is being done here. And there's all sorts of other things here to consider, too. And I hope you look at this with some excitement because you're in a great place to be right now. A few things. There is a small cadre of people who are starting to really, especially economists, who are really starting to be very interested in this concept, as well as people who are doing the fundamental underlying research in terms of what kind of technologies will improve things like moving block, which I think is an exciting technology. There's a lot of other technologies that are going on out there in the rail world. A lot of other things. In fact, I just came back from Fort Worth last week, and Matt Igo was talking about how they're using drones to monitor whether or not they got the right culture out there, whether people are doing the right things without so we say, having somebody supervising them. There's really a lot of fantastic, and railroads are moving quickly. They are very technologically oriented. So I don't think this is going to be a problem. I think they're going to adopt it. Changing their basic economic models might be a little more difficult for them. So anyway, let me stop. Questions? Thoughts? Yes?
Just a couple of comments. First is, if you sort of follow to its logical conclusion this idea of sort of mini trains, right? One of the more challenging economic problems in the industry, as you know, has been the fact that you've got this huge investment in track, right? Track that is sitting there idle 99% of the time, on the clock, waiting for you to run a 150-car train down it, and then it sits there idle for another hour, right? If you could transform your operating model to one in which you're running these sort of micro or mini trains every 5 or 10 minutes, I think at that point, when you say you've got the truck industry and the rail industry in competition, I think that is no longer the case, right? I think you've revived this concept of intermodal shuttles, of more rapid intermodal transfer from rail to road,
Right.
using rail for the long haul, truck for the drayage, all these kind of models I think take place, right? You basically have made, I think, sort of revolutionized the idea of intermodal traffic at that point, because you've made the rail infrastructure something that the trucking industry will actually view as an asset, right, rather than the competition potentially. The other comment I would make is that same thing, if you start to think of trains as getting shorter, faster, better schedule guarantees, the ability to accelerate and decelerate faster, you've transformed what we think of as a freight train into what's essentially a passenger train model. So I think you are reducing to some extent with this type of transition, you would be making it significantly easier for passenger and freight to interoperate in these urban environments, right? So I think from a regional passenger rail and a commuter rail standpoint, there are some very exciting options there too. So I think this is sort of I didn't really know what to expect when I heard this talk, but this is,
There's all sorts of
amazing
possibilities.
opportunities here.
Let me just I got to try to rephrase this as I'm recalling. And that is, a couple things happen with these concepts. One is that I don't think we'll ever get rid of the truck industry, primarily because there's a cost of putting a track into your service.
Sure.
And there's a lot of issues there. In terms of running more efficiently with interoperable with passenger trains, because you've got smaller trains, faster, if you will. I don't know if they're going to be faster in the speed sense, but they'll be faster in the logistics sense. That very well could be. Because I remember when I was at Metro in Chicago, we really had problems with these big trains coming in and clogging up a network we had been investing a lot of money in through I think it's the faster project there. And they tend to clog up stuff, and they really are not that compatible with passenger trains, although there's a lot of other distinctive differences between them. So I do think it makes it much more competitive with truck. We're going to always need truck is the last mile. But I think there's still a lot of stuff we could pull off the highway.
And to clarify what I was envisioning is right now the big issue with intermodal for fast freight is your truck takes the thing to the terminal and it sits there all day waiting for you to build up this intermodal train. Right?
Yes.
If you can push that thing down the track as soon as it shows up,
That's right.
that changes things a lot.
It certainly reduces the batch size. And from an economic standpoint, of your total cost, the less fixed costs you have and the more variable costs you have, the smaller batch sizes you need. Right? Think about books. We used to have to print books in, tens of thousands of quantities because you set your type and then you print it. Put 10,000 into inventory. A lot of them get wasted. I used to pull off, one of my first jobs was pulling off covers off of books that didn't sell. And now we can produce books in batches of 1, 2, or 3 on demand. Those are the most efficient plants. Those are the ones that are that are really taking over that world. I don't know if it's completely converted, but think about it. The lower your fixed cost, for example, on the books, setting it up and getting it printed going, the lower your fixed costs, I can produce 1 or 2 efficiently and sell it to market. Yes, Chris.
I'm afraid I'm going to disagree with it, Chris, a little bit. And we should be using the mic, by the way, sorry. So I'm not at all convinced that, especially in a busy passenger corridor, that this more shorter trains are going to fit in very well. They're going to use up already precious slots. Number two, the passenger trains keep stopping. These trains, you don't want them to stop, so they're going to get in each other's way. So that's that. I think, I mean, one of the first conversations we ever had about this idea was a year ago, Avery, and I'm not being a skeptic, don't get me wrong, but I do think one of the things that's not on this research list is just really some relative, well, I don't want to say simple, but some capacity and train spacing and analysis to really understand, can you actually get more capacity over a given piece of infrastructure by running, 20 small trains versus 3 or 4 big trains. And a third thing that I think is, and again, I don't want to be a skeptic, I love the idea here, but,
No, go ahead.
but how do you overlay this new operating approach over the existing operations,
So I need to repeat that for our web audience, I think.
No, because I was...
Okay, that goes into the web audience. Okay, let's talk about your first point, and let me tell you, I'm skeptical of some of this too. I tell you, because trying to think 10, 20 years in advance, things are not going to turn out that way. You can almost bet that part. And whether or not we can get enough efficiencies on capacity so that running 20 small trains versus, we'll say 5 big trains, whether we can do that on the kind of infrastructure we've got, that's questionable. I think that's where a lot of the research has to go. And I think that's where some of the research is going to go in terms of what is the true cost of running small trains, more frequent small trains in terms of capacity. We have to understand that. The second part of that question, I forgot. No, I'm getting old.
Yeah, I've already forgotten too, but.
Oh, the incremental nature of implementation. Okay. How would this be implemented? And I think the answer is to some degree, it is already implemented conceptually, origin, destination, and the whole concept of unit trains, right? Origin, destination, you call them shuttle trains. I call them unit trains just because our nomenclature is a little different, which really did run from origin to destination and back. And they were popular because their costs are lower. All right, we still had crews and all that stuff, but we didn't have intermediate switching. So the way I see this potentially coming about is intermediate trials. It will start with the big customers. It'll be the automobile. It'll be GM and LA. Of course, we are already running automobile trains, but part of the PSR is we don't want to run unit trains. But I think we can start with big customers that already have they can run a full small train every day if they wanted to. And let's start seeing if this actually works. Now, that's on the small train basis, but on the automation effects, whether we get to the remote side, I do think there will be trials. And from my understanding I just learned about this upon this visit, is that the French are already running some remote control type operations with a crew on board, but they're attending the train and somebody's running it remote. So how that function steps incrementally, I don't know. But I do think what we'll begin to see is trials. And then we'll begin to see commercial applications. And then we'll see more of a changeover. It's like anything that's going to occur, it won't happen at once. It's got to be tried in steps. And then we'll learn from every step for the next iteration. I'm sorry, Chris.
Avery, yeah, thanks again for your wonderful presentation. And some of your comments, I think I have to be a little less skeptical than Chris because I'm doing a lot of the research in this area, so I can keep my students excited about this.
I'm counting on you.
But,
in your group.
I think, if you look at, there's an entire continent where, because of regulations, you're forced to have short freight trains, right, in Europe, and most of them are operating with a single person crew. And so you look at some of the boutique, I'll call them freight operations that have emerged in Europe. You know, you've got, you know, the Carlsberg beer train, things like that, or our friends from KTH, there's the co-op supermarket train that does a loop around Stockholm and serves all the supermarkets via intermodal in this big loop every day. Things you'd never imagine doing with the long train focus currently in the US, and suddenly they have, like, you know, because of restrictions on the train sizes, they have these short, frequent freight trains, and they're doing all these different things that are providing a much different service to the freight customers. So I think in that respect, you know, there is a lot of potential. Think about what could happen if you are able to do this, you know, implement this. But obviously there's a whole lot of technology challenges. So I don't know if there's a question there, but that was more of a comment. I think, you know, so I think there's some of these different things are to focus on, but what do you think is what would cause the first domino to fall in terms of going down this path? What do you think is the impetus or the biggest obstacle that would have to be overcome if you start checking off a number of these boxes that it starts making sense?
So what are the steps? What are the big obstacles? Obviously, I think the technology is continuing to evolve. That's a continuous thing. They're going to continue to work on how to make a remote control train operation work. And I do think the concept about having, they're still engineers on these trains, so they're just not physically on those trains. And I think that has a lot to do with it. The biggest issue, the biggest conflict, I think, is the potential conflict with rail labor. If rail labor, this is my personal belief, and I don't know who's listening, but if rail labor and management got together, and I think some of the regulators, and said, what do we want to do for the future of this industry? How do we make this industry a long-run success better than it is today? Then I think the kind of cooperative and the benefit sharing kind of concepts will come to the surface. And once that's understood and agreed upon, then I think we'll see a fantastic impetus to drive forward to this. So that's the biggest issue is our T&E rail labor. And I don't want to, and believe me, you know, I come from an era back when we had a lot of labor, and rail labor has, I won't say suffered, but they have diminished in numbers. But these jobs have gone from, I think, to become much better paying jobs, much more, they're better paying jobs, I'll put it that, than they were, I think, back in my day. But labor, I think the idea of benefit sharing will move this along faster than anything else. So technology benefits more than just investors. It could benefit customers, it could benefit labor.
Other questions?
Yeah, and it's easier for me if you use the mic, because then I don't have to remember what you said.
Where do you see electrification fitting into this?
I think electrification is a separate issue. That's, to me, that's really about density and capital. What kind of capital requirements are going to be needed, what the cost of electricity is. If you're asking from an environmental standpoint, where's the power being generated, you certainly have to have a big base load for this thing. So I don't see that as necessarily playing into this, but I do see places like eventually California would require trains to be electrified, but where are they going to get the power? Arizona? I don't, anyway, so I see this as a separate issue.
I have a question related to the PSR. Since most of the railroads are running longer and heavier trains as a part of implementing PSR, do you think they are on the wrong track, or say if PSR is already successfully implemented with better service design, better operation, better working efficiency, do you think shorter trains still have better performance than longer trains?
Well, there's a lot to that question. And I think the concepts behind precision schedule railroading are ones that have been around for a while. They have the added emphasis of asset utilization, because part of this is to not have to buy as many locomotives. So driving, I'll call it slop out of the system, has always been a key management objective. It's just sometimes we have to regenerate that concept. So to the extent that PSR is all about improving discipline in the operations, running trains on time, not always throwing on an extra unit because one might fail, those kinds of things, positive train control will drive additional benefits. The question is fundamentally, I think, whether the move to longer trains is really one that helps not drive down just cost and operating ratio, but if it does it, to what degree is that really helping customers? Because in the end, we don't exist to just be a railroad. We're there to serve customers. And we've got to look at things from the standpoint of what is the best thing for the shipping public out there. And I don't think personally that long trains are really good for that, except if they're really run much more in a much more disciplined manner than it is. I'm not sure if I've answered your question well, but follow up. So I'm going to talk about, we need economists. This program, too many people who want to think about costs and markets and things like that. So if you have friends in the business world, you might talk to them about what would this do to our supply chains. Chris?
Yeah, I do have one more question about the technology. The title is about remote control trains, and I guess what I'm trying to understand is the vision here that you have a single operator sitting at a centralized train operating control center, and they are remotely controlling the train, or are these trains sort of semi-autonomously operating and the remote train driver is stepping in and taking over when necessary?
Yes, is the answer. And I skipped over that, and I got into that a little bit after the fact.
I think it's an important distinction.
It's a very important distinction. These are the way I'm envisioning it. And again, this is just my vision, is that we have computer-run trains, and the engineer steps in when he needs to. And there should be signals and flashes that says, okay, we've got a decision that's coming up here. We're going to need your input. Theoretically, for example, some of these self-driving cars, the guy is supposed to be there in the driver capacity, and the car drives itself until we can't make a decision. You need to take control, and he's got 8 seconds to take over the car. I think we can do a lot better job of saying, okay, in 5 minutes, Mr. Engineer, remote engineer, we're going to need your intervention because we're going to have start having to need some human intervention making decisions around running the train. My sense is that the computer technology will basically, it's just like today in planes, airplanes. Generally speaking, the plane actually could do a better job of taking off, flying, and landing itself today. I think that's where most of our computers are now with flights. The pilot is theoretically there to do two things. One is to reassure people that when things go wrong, there's somebody there to take over, but also to be there in the event something happens, not to actually fly the plane. And now that's considered to be starting to be a problem in some areas, because then people aren't actually flying the planes, and when something goes wrong, then you got to figure out, get back into the mode of flying it. But I do see this as a intervention type of operation.
Call it computer-aided train operation or something
Yes.
like that.
Yeah.
But I would also bring up something I've been hearing pretty much my whole career about these sorts of technologically assisted operations of this sort, which is that if the driver is not in frequent control, they kind of lose their edge. And so it's a trade-off. And I think one of the reasons why the railroads have chosen to adopt PTC, where the locomotive engineer is really operating the train, PTC only steps in when something is, they first warn the engineer, and then they take over if they fail to respond appropriately. That keeps the locomotive engineer, sharp and totally attuned to what they need to be doing to successfully execute their job. So I'm not saying that doesn't work here. I'm just saying I think there's a whole bunch of human factors elements of this that would also need to be worked out, which you could add to your, there you are, safety risk management human factors.
Well, absolutely, Chris. And let me put it this way. This could even work if we had that same kind of operation. The guy was one-on-one with the train. You would still have some savings. You'd still go from two-man crews to basically a one-man crew in a remote location. But you know all the costs you'd save? The deadheading, the housing, the busing, overtime, and so forth. You'd still have tremendous cost savings even if you had one-on. And we don't know. That's a big part of the research that has to be done. And how do you go from 2 to 1, and then from 1 to an attendee, he's on the train just in case, and he's take over, to a remote control type operation. I mean, again, this is, I'm not saying, this is a vision. It's not, it's a little bit of a blue sky vision.
That's fine. You don't have to
But that's
apologize.
my,
That's what you're here for.
but I don't have any strong feeling, but I do think eventually we will be able to get, but that is a big issue. Complacency.
And another thing you and I discussed the other night is, one element of the technology could be every locomotive has a drone alongside it, or with it, or mounted on it, and when it needs to take off and go check things behind or ahead, it can be part of the integrated technology.
I think that's a great idea, because sometimes you do want to see what's going on at the end of the train, or if there's an incident, we want to be able to go inspect the train. There's no crew there to inspect the train if something happens, and they got to go figure out, oh, we're getting some strange brake line issues here. And if you had a drone, you could be right there. Actually, you could be there faster than if you had a crew on board, because you wouldn't have to walk. The thing would, and it's a small enough component that could be easily fitted onto a locomotive. We'll go check. Let's see is there a hot box here? Which car?
The drone with the temple stick.
Well, X-ray vision,
The drone that could carry a coupler knuckle.
Yeah, well, I don't know about that. But knowing what's wrong, so when the guys do show up, they have the right equipment
Well,
with them.
that's where your roving conductor comes in.
Yeah.
There are people on the ground, they just may not be right at the train at the moment.
Right.
Any other questions?
All right.
Thank you very much.
Thank you.
And I also want to offer another bit of thank you, which as I mentioned, Avery was a student of William Hay back when Professor Hay was leading the rail program several decades ago. And had for many years had a copy of Hay's textbook, which many of you are familiar with, on his shelf. And apparently that disappeared at some point. So we're going to replace it.
Oh, my. Fabulous. Thank you very much, Chris. Yeah, this is going way back. So, again, thank you very much. And again, my point here has been to pose some thoughts for you to figure out. So, all right. We're done? Can I take these off? Okay.